Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha. May God be pleased with her online college, studying A-level maths year 2, pure maths, and we're looking at trig identities. Let's begin with today's question. Bismillah ar-Rahman ar-Rahim. Today you have to prove that 2 sine theta over 2 times cos theta over 2 times cos theta is equal to or identical to half sine 2 theta. We've done a couple of these before. Hopefully you remember the technique. We either start with one side, the left-hand side, and work on it, try and simplify it as much as possible until it looks like the right-hand side. Or we start on the right-hand side, work on it, simplify it until we get it to match what's on the left-hand side. Normally you pick the one that's longer and easier, and then you've got more opportunity to work with it. So that's what we're going to do. We are going to pick the left-hand side, and then we're going to try and use everything we know to work on this and make it look like the right-hand side. So that means we can take the right-hand side away. We don't really need to work on that just yet. We just need to work on this, make sure by the end we've got something that looks like half sine 2 theta. So let's work on this, and the first thing you want to notice is that we've got sine of an angle times cos of an angle immediately one after the other, and we've got a 2 at the front. So when you see that, you want to think of your 2 sine theta cos theta identity. So we learnt it as sine 2a is equal to 2 sine a cos a. Notice you got the sine and the cos straight away after each other, and you got the 2 at the front. So this right hand side here is going to be helpful to work on this bit here. So let's just go through the basics. A is any angle. So whatever the angle is here and here, then the angle on the left hand side is going to be 2 times that, or double of that. So just to give you another letter, just so you get used to seeing different letters. If I had x and x as my a, then on the left I'm going to have 2x, sine of 2x. If I had y and y, then I would have 2y on the left. And the trick to realize is that it works with any angle. So we could even make that angle here, instead of x or y, we could make it x over 2 and x over 2. And then on the left, we would have double of that. So that's just x. So notice how it doesn't really have to be a full angle on the right. So that's what we're going to do here. We're going to say, look, really the a's are theta over 2. So if I write theta over 2 for my a, then double of that is just going to be theta. So my identity is going to be sine theta is equal to 2 sine theta over 2 times cos of theta over 2. That's just filling in the sine 2a formula with theta over 2 as our angle for a. And now if we compare, this bit here matches this bit here. So that means I can take all of this away and put that on this side. It's an exact match, which means the left-hand side can go in its place. So the left-hand side was sine theta can go in its place. So now it's just sine theta cos theta. And now you got to realize, well, hold on, that again is very similar to what I had at the beginning, which was sine 2a equals 2 sine a cos a. This, if I had my a as theta, then my 2a would be 2 theta. So it's almost the same. I'd have 2 sine theta cos theta on the right, and I'd have sine 2 theta on the left. It's not quite the same because here I don't have that 2 at the front. It's missing. I've got nothing at the front. So what I'm going to do is say, okay, let me just do a bit of rearranging. So this 2 I can divide by 2 on both sides. So that can come here. So now it is an exact match. So what I've got here is an exact match of what I've got here. So I can replace all of this. Sine theta cos theta can come here. Sine theta cos theta. And all I need is this sine 2 theta over 2. That's just 2, normal 2, not minus 2. So let's write that properly. So I've got sine 2 theta over 2. So I've simplified and simplified as much as I can. There's nothing really more I can do. So now it's just to compare. How does it compare to what we wanted? We wanted to get half sine 2 theta. Well, I've got my sine 2 theta, and just to get the half, I just need to bring this 2 across and write it as 1 over 2 instead of divide by 2. So half sine 2 theta is what I end up with, and that's the proof done. So just to make sure you got that, let's just quickly revisit. The key was to look at what we're starting with and see that the sine 2a formula is going to help because the right hand side looks very similar to what we've got at the front here. We just have to think carefully about, hold on, what's my a going to be? Looking here, I see that the a would be theta over 2. So if the a is theta over 2, you can fill the a as theta over 2, and then your 2a would just be double of that, which if you think about that, that becomes just theta. So you've got sine theta is equal to 2 sine theta over 2 cos theta over 2. That's an exact match, so that can be swapped. So now you've got a much easier thing to deal with, but still a bit more simplifying to do. Sine theta cos theta still looks like the sine 2a formula is going to help. This time the a would be theta. So then the right hand side looks a, very much like it, but the 2's in the way. So if you take this 2 here onto the other side, you'll end up with sine 2 theta over 2 equals sine theta cos theta. That's an exact match. So then we can swap the sine 2 theta over 2 for that. And then very close, compare it to what we needed to get. And it's just, we need to put a half at the front rather than as a divided 2. Join me for more tomorrow. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be